Have you ever imagined something so dark it swallows light itself? A place where not even photons can escape? Welcome to the world of black holes, cosmic mysteries that seem silent and destructive. But what if I told you these dark giants can also shine, blasting particles and energy across thousands of light years? Today, we're diving into black holes and cosmic radiation jets. Darkness that shines. Fact 1. What cosmic radiation actually is. Imagine you're sitting outside on a calm night looking up at the sky. Everything feels peaceful, quiet, almost empty. But the truth? Space is anything but quiet. Above your head, every second, millions, yes, millions, of tiny high-energy particles are slamming into Earth like invisible raindrops. You can't feel them, you can't hear them, but they're there, constantly moving, constantly hitting, like the universe whispering, "I'm here." That invisible shower? That's cosmic radiation. Cosmic radiation isn't like the radiation you picture from movies with glowing green goo and hazard suits. It's a mix of incredibly energetic particles flying through space at speeds close to the speed of light. Some are tiny pieces of atoms, protons, electrons, even heavier nuclei, while others are bursts of electromagnetic energy like gamma rays, and they've been travelling across the universe for thousands, millions, even billions of years before arriving here. That's kind of poetic, isn't it? A particle born from a dying star halfway across the galaxy eventually lands on your shoulder while you're eating a sandwich. Now, here's the strange part. We don't really notice them. They don't make your hair stand up or give you superpowers. You don't walk outside and say, "Oh wow, the cosmic radiation is strong today." But it's always happening. If you've ever had a random computer glitch or your phone froze for no reason, sometimes, just sometimes, a cosmic particle may have zipped right through the electronics and caused it. It's wild to think that something from the edge of the universe could crash our laptop, but hey, space doesn't care about warranty. Cosmic radiation matters because it tells us that space is alive. Not alive like trees or birds, alive with energy. It's part of the reason astronauts need so much protection. It's why spacesuits aren't just shiny outfits. Up there, outside the blanket of Earth's atmosphere and magnetic field, these particles hit harder, more directly. We'll talk about that later when we get to the dangers in space. That's a whole different story, trust me. For now, just picture it like this. Earth is standing in a cosmic rainstorm. We don't see the rain, but it's falling, constantly. Every planet gets hit, every moon, every spaceship, every person. It's one of the quiet ways the universe reminds us that even in the calmest moments, there's always something happening out there. So the next time you look up at the night sky, remember, it's not empty. It's buzzing, glowing, firing, travelling, raining, all at once, and we're right in the middle of it. Fact 2. Difference between cosmic rays and cosmic radiation. Let's clear something up because this part confuses almost everyone at first. Cosmic rays, cosmic radiation, aren't they the same thing? They sound like they are. Even scientists sometimes switch the terms casually, and honestly, it's understandable. But there's a little difference that makes everything easier to grasp once you see it. Think of cosmic radiation as the whole package, the umbrella term. Everything energetic coming from space, whether it's a particle, a beam of energy, a wave, it all fits in that category. Cosmic rays, on the other hand, are a specific type inside that umbrella. They're actual speeding particles, mostly protons, flying through space and eventually reaching Earth. In simpler words, cosmic radiation is like saying music, and cosmic rays are like saying drums. Drums are music, but music is more than drums. Cosmic rays are part of cosmic radiation, but cosmic radiation includes more: gamma rays, X-rays, even high-energy light. That might feel like a small difference, but it matters, especially when scientists talk about how these things interact with Earth and with us. The universe throws a lot at us. Some of it is particle radiation, little atomic pieces travelling like bullets. Some of it is wave radiation, waves of pure energy flying through space. Together, cosmic radiation. Separately, cosmic rays are the particles, the tiny bullets, and they really are tiny. You'll never dodge one, you'll never see one, yet they can punch through spacecraft, through the atmosphere, even through you. Don't worry, most of the time your body repairs any tiny damage before you even feel anything. Nature's pretty amazing that way. On Earth, our planet is like a giant protective bubble. The atmosphere absorbs most of the particle rays. What gets through is small compared to space, where astronauts deal with the full cosmic chaos. And when we talk about missions to Mars later, trust me, this difference becomes a huge deal. One radiation type needs thick shielding, the other requires smart technology and protective planning. So if someone asks you, what's the difference again? Just picture space throwing little particles and waves at us. The particles, those are cosmic rays. The whole invisible storm, that's cosmic radiation. Simple, smooth, and honestly kind of fascinating once you picture it flowing through the universe like an invisible river of energy. Fact 3. Origins. Solar versus galactic versus extragalactic. Have you ever wondered where all this cosmic radiation actually comes from? Like, who's sending it? Why is space full of these wild energy bullets in the first place? That's one of those cosmic questions that makes the universe feel way bigger than our brains can hold. Cosmic radiation has 3 main neighborhoods of origin: the Sun, our galaxy, and everything beyond. Let's start close to home, the Sun. Our star isn't just a warm, glowing ball that gives us sunlight and tans. It's constantly throwing energetic particles into space like confetti at a never-ending celebration. Solar flares, solar storms, they blast out radiation that hits Earth more often than we realize. This is the more local kind of cosmic radiation. Still powerful, but kind of like having noisy neighbors. Annoying sometimes, but familiar. Then there's the galactic source, meaning our Milky Way. This is where things get dramatic. Massive dying stars explode, creating supernova blasts that shoot particles across the galaxy like cosmic shrapnel. Pulsars spin so fast they throw beams of energy like space lighthouses. Magnetars twist magnetic fields so strong they make atoms scream. The Milky Way isn't quiet. It's a factory of chaos, power, and creation. And through that chaos, radiation is born. Finally, there's the extragalactic stuff. Energy that comes from other galaxies. Imagine something so powerful it sends particles across millions of light years and they still have enough energy to hit Earth. Black holes spitting jets at near-light speeds, galaxies colliding, quasars roaring in the darkness. Yeah, the universe doesn't play small. When one of those particles reaches us, it's like catching a message mailed from another reality. A tiny stamp of violence and beauty. Older than our entire civilization, so whenever cosmic radiation hits Earth, whether from our sun, our galaxy, or the deep universe, it's like getting postcards from different corners of existence, and each one tells a different story. One day we'll talk more about those galaxy explosions and black hole jets. That's a whole chapter on its own. For now, just imagine the universe constantly talking to us, even if we don't always know how to listen yet. Fact 4. Discovery of cosmic rays. There's something magical about scientific discoveries that happen by accident. You know, when someone's looking for one thing and ends up stumbling into a secret, the universe has been hiding forever. Cosmic rays? Yeah, that was one of those stories. Back in the early 1900s, scientists already knew a bit about radiation thanks to discoveries like X-rays and radioactivity. But something strange kept happening. Instruments kept picking up radiation, even when there were no radioactive materials nearby. It was like the universe was whispering, "Look closer." Some scientists thought it must be coming from Earth, maybe rocks or soil. Others weren't convinced. Enter the balloon experiments. Researchers noticed that the radiation levels didn't drop when you moved equipment away from the ground. That made no sense, unless the radiation wasn't coming up from the Earth, but coming down from above. It was a shocking idea at the time. Space? Sending radiation here? Sounds obvious now, but back then it was like saying the clouds could throw lightning before anyone knew what lightning was. Bit by bit, experiment by experiment, the clues added up. Scientists carried detectors to mountaintops, flew them on balloons, placed them underwater, trying to solve the mystery. And eventually the truth clicked into place. Radiation from space was constantly reaching Earth. It wasn't coming from the ground at all, it was cosmic. That discovery changed physics forever. It opened doors to studying particles that man-made machines couldn't yet create. It helped build our understanding of high-energy physics, stars, and even the structure of the universe. Funny how something you can't see, touch, smell, or hear turned out to be one of the most important clues in understanding reality. Sometimes the biggest discoveries come from paying attention to the things that don't make sense. That little "this is weird" moment, it can rewrite science. And cosmic rays were the perfect example. Fact 5. Victor Hess and the balloon experiment picture this. It's 1912. There are no satellites, no spacecraft, no fancy space telescopes, just human curiosity and courage. And a man named Victor Hess, a scientist so determined to solve a mystery that he literally lifted himself into the sky to find answers. At the time, people didn't fully believe radiation could be coming from space. It sounded wild. So Hess designed an experiment that today feels almost cinematic. He built instruments to measure radiation and decided to take them up in a balloon, not just a little flight, but soaring miles above the ground. You know those hot air balloons people ride for fun now? Imagine that, but without the modern safety gear. No GPS, no radio, just wind, rope, and raw determination. As he floated higher, breathing thinner air, the instrument started ticking faster. Radiation levels rose instead of falling. Imagine seeing that. Watching numbers climb the farther you floated from Earth. He didn't stop. He went even higher. Higher than anyone measuring radiation had ever dared. And up there, suspended between Earth and the unknown, Hess found proof. Radiation was entering our world from above, not below. That flight changed everything. It earned him a Nobel Prize later, but more importantly, it opened humanity's eyes to the universe beyond our skies. If you think about it, he was one of the first explorers of invisible space. Not stars, not planets, but invisible energy raining from the cosmos. A pioneer without a rocket ship. Hess's experiment reminds us that science isn't always about machines and labs. Sometimes it's about bravery and curiosity, about trusting your questions enough to chase them into the sky. And thanks to his flight, we now understand that Earth sits in a constant storm of cosmic radiation, a storm we're learning to measure, to shield from, and someday to travel through. And that was just the beginning. We haven't even reached the wild parts yet, like what happens to astronauts out there without Earth's protection. But we'll get to that soon, one discovery at a time. Fact 6. How cosmic rays travel through space. Think about throwing a stone across a calm lake. It moves in a clean line, a simple path, until it finally sinks. Now imagine throwing that same stone into a hurricane. It would twist, spin, bounce, and fly in directions you never intended. That messy, unpredictable journey. That's closer to how cosmic rays move through space. We like to picture space as an empty, silent nothing, a straight path from point A to point B. But in reality, space is full of magnetic fields, tangled, stretched, twisting around stars and planets, swirling through galaxies. So when cosmic rays are shot out from a star explosion, or fired like bullets from a black hole, they don't get an easy ride. They get tossed around like confetti in a storm. These particles travel at speeds close to the speed of light, insanely fast, but it's not like they pick a direction and go. They zigzag, they spiral, sometimes they bounce off magnetic fields like invisible walls. A particle might be meant for one star system, but gets yanked around by gravity and magnetism until it ends up in a totally different part of the universe. That randomness is part of why figuring out where a cosmic ray came from is so hard. By the time it reaches us, its path has been scrambled so much it's like reading a message that's been crumpled, erased, and rewritten 100 times. Some rays travel for millions or even billions of years before arriving. Imagine that. A tiny particle born in an ancient cosmic event, travelling across generations, across civilizations, rising and falling, just to land in our atmosphere today. It's humbling, really. A reminder that the universe isn't slow just because it looks peaceful. It's constantly in motion, constantly firing energy across unimaginable distances, and yet, even with all that chaos, these rays still find us. They slip through the galaxy, past dust clouds and solar winds, around planets and stars, and eventually, they land here. On our world, on us. You never feel it, you never notice it, but those particles have made a journey more epic than any road trip ever taken on Earth. Sometimes I like to imagine them like cosmic travelers, tiny explorers with no destination, surviving storms of magnetism and gravity, racing through the universe because that's simply what the universe does. It moves, it sends, it connects, and we're here at the receiving end, catching tiny pieces of distant stars without even trying. Not bad for a planet spinning quietly in one corner of space. Fact 7. Cosmic radiation versus normal electromagnetic radiation. Let's pretend you're sitting near a campfire. The warmth on your skin, the glow you see with your eyes, that gentle crackling sound. That's energy moving around in different forms. Now stretch that idea out to the universe. Space has its own energy fire, except instead of cozy warmth, it's blasting particles and waves across light years. That's where we separate cosmic radiation from normal electromagnetic radiation. Electromagnetic radiation is what you already know. Light from the sun, radio waves powering your Wi-Fi, microwaves heating leftovers, X-rays at the dentist. It's energy moving in waves. No physical pieces flying through you, just waves vibrating through space. Smooth, rhythmic, like ripples in water. Cosmic radiation, though, is a little more dramatic. Instead of just waves, you get particles. Chunks of matter from exploding stars and violent cosmic events. These are atomic missiles, tiny but powerful. They don't just pass by politely like light waves. They crash into atoms. They knock electrons loose. They slice through cells. It's messy, aggressive energy. Here's a way to picture it. Electromagnetic radiation is like music traveling through air, reaching your ears gently. Cosmic radiation is like someone throwing pebbles, or sometimes boulders, at you from across the room. Different vibe, right? But here's where it gets interesting. Not all cosmic radiation is particles. Some of it is electromagnetic, like gamma rays. So the two worlds overlap. Space doesn't always keep categories neat and tidy. It likes mixing things up. And while everyday electromagnetic waves are harmless at low levels, your radio isn't going to melt you. Cosmic radiation doesn't always play nice, especially outside Earth's atmosphere. It's why astronauts deal with higher cancer risks, why spacecraft need shielding, why we worry about solar storms frying satellites and power grids. It's also why studying this difference matters. Waves tell us about light and information. Particles tell us about the violent, powerful processes building and breaking the universe. Both are energy, both travel across space, but one whispers and one collides. And yet, they're both reminders that even in the dark, empty-looking sky, something is always moving, always traveling, always reaching us. Fact 8. What particles? Cosmic radiation is made of, picture the universe as a gigantic fireworks show. Stars exploding, galaxies colliding, black holes swallowing gas and spitting energy. Every burst sends debris flying. Not colourful sparks we can see, but tiny subatomic pieces we can't. That cosmic dust. That's what cosmic radiation is made of. Most of these particles are protons, little pieces of atoms like tiny building blocks of matter. They make up about 90% of all cosmic ray particles. Then there are alpha particles, basically helium nuclei, a bit heavier. Like the universe tossing pebbles instead of dust. And beyond that, you get heavier atomic fragments, even iron or nickel nuclei travelling at insane speeds. Imagine an atom ripped apart in a stellar explosion, then one chunky piece racing across space for 1,000,000 years just to end up hitting Earth. That's cosmic drama. But cosmic radiation isn't just made of matter pieces. Some of it is high-energy electrons zipping through space. Some of it is gamma rays, the high-energy light bursts that are pure energy, not matter. And then there's the exotic stuff, rare particles like positrons, the antimatter version of electrons, and neutrinos that barely interact with anything at all. Neutrinos pass through your body right now, millions per second, and you don't feel a thing. They don't stop, don't collide, don't even slow down. Ghost travelers. When cosmic particles crash into Earth, things get even crazier. They smash into air molecules and shatter into new particles, like tiny cosmic billiard balls breaking apart. We'll talk more about that when we get to primary versus secondary rays, because that chain reaction is an entire story on its own. But for now, imagine the universe as a workshop constantly breaking and rebuilding matter. These particles are the scraps, the leftovers from cosmic engines, and they tell a story. A proton that hits Earth today might have been born in a star that died before humans ever existed. A neutrino might have passed through entire planets before brushing past your shoulder. We walk under a shower of ancient particles every day, and most of the time we don't even notice. But they're there, reminders that matter doesn't stay still, that energy travels, and that the universe never stops moving. Fact 9. Primary versus secondary cosmic rays. Imagine a snowball rolling down a mountain. At first it's small, pure, simple, but as it rolls it smashes into snow, picks up more, breaks pieces apart, and soon you have a big messy ball with extra chunks flying everywhere. That's the difference between primary and secondary cosmic rays, only instead of snow, we're dealing with atoms and particles. Primary cosmic rays are the originals. The ones born in space, fired from stars, flung from black holes, launched by supernova explosions. They spend ages travelling through space until they finally crash into Earth's atmosphere. Think of them like the first raindrops in a storm, direct from the sky. But here's where things get fun. When a primary cosmic particle hits the atmosphere, it doesn't just stop, it collides. Hard. It slams into oxygen or nitrogen atoms and breaks them into pieces. Suddenly one particle becomes many. These new fragments shoot downward. Muons, electrons, neutrinos, and other strange particles. These are the secondary cosmic rays. They weren't born in space. They were born right above us, created by impact. So when cosmic rays hit Earth, it's not just one tiny visitor from space. It's more like a mini explosion, a cascade of particles spreading downward in all directions. By the time the shower reaches the surface, what started as one energetic traveller has turned into dozens, sometimes hundreds of particles. Some reach the ground, some go deep underground, some even pass through buildings as to through you, and keep going. And here's a twist. Most cosmic rays we detect on Earth aren't primary at all, they're secondary. The atmosphere does so much of the work breaking them apart that what reaches the ground is basically the cosmic echo of something that happened miles above your head. It's like the universe throws a stone at Earth, and by the time it lands it is shattered into pebbles. We don't feel them, we don't see them, but they rain down constantly. It sounds dramatic, and it is, but it's also normal. This has been happening long before humans ever looked up and wondered why. Fact 10. Why cosmic rays are always hitting Earth. There's a quiet comfort in believing Earth is isolated, a little blue planet floating calmly in space. But the truth is, we live in a cosmic storm, not a storm of wind or water, but a storm of particles and energy constantly falling from the sky. If you ever felt the world was too quiet, here's a reminder. Space is always knocking on our door. Cosmic rays are always hitting Earth because the universe never rests. Stars explode all the time. Black holes flare. The sun breathes energy like a living creature, blowing particles across the solar system. And space doesn't have walls. There's no place to hide. We are exposed, beautifully, naturally exposed, to the universe around us. Earth does have defences, though. The atmosphere catches most of those particles. The magnetic field pushes many away. Without them, life here would look very different, maybe not exist at all. So even though particles rain down constantly, we only experience the gentle leftovers, like hearing thunder far away but getting only the soft sound, not the strike. Some of those particles never stop. They zip through Earth and come out the other side barely slowed. Others react in the air above us. Some hit electronics. Ever had your computer glitch for no reason? Yeah, sometimes the universe taps your circuitry just to say hello. The reason they never stop coming is simple. The processes that create cosmic rays never stop happening. Space is active, chaotic, dynamic. Every second somewhere a star ends, a new one begins, magnetic fields twist, galaxies collide. And through all that activity, radiation is thrown like sparks off a grinding wheel. We don't notice it. We go to work, we laugh with friends, we sleep peacefully while cosmic particles pass through our bedroom walls, but they're always there, like quiet background music coming from the universe itself. And honestly, there's something comforting about that. We're not alone in silence, we're connected, touched by energy born in places we may never see, from moments billions of years old. It makes you wonder, if so much is happening out there without us noticing, what else is waiting to be discovered? And how many more quiet cosmic visitors pass through us every day without a sound? Fact 11. Radiation from the Sun, our nearest cosmic particle engine. We think of the Sun as a warm golden orb in the sky, the giver of light, heat, and life. But behind that peaceful glow is something far more powerful, a roaring nuclear furnace launching a constant storm of particles into space. This stream is called solar radiation, and it's Earth's closest and most continuous source of cosmic rays. Inside the Sun, atoms are smashed together in nuclear fusion reactions. This process creates huge amounts of energy, some of which escapes as light and heat, the parts we notice daily. But along with warmth and sunlight, the Sun also hurls out a fast-moving ocean of charged particles, mostly protons and electrons. This steady flow is called the solar wind. Most days, we don't even realize this invisible storm is washing over our planet. Earth's magnetic field quietly shields us, guiding most particles safely around the planet like a force field. But sometimes, the Sun erupts violently, in explosive events called solar flares and coronal mass ejections. In those moments, it throws out a sudden blast of high-energy particles that can reach Earth in minutes. When that happens, technology feels it first. Satellites can glitch, radio communication can fail, astronauts in space stations are suddenly vulnerable, and here on the ground, we might see something beautiful, glowing auroras dancing in the sky, painting the night with green and purple light. Those lights are cosmic radiation colliding with our atmosphere and releasing energy. So yes, the Sun nourishes life, but it also constantly tests Earth's defenses. Every sunrise carries warmth, but behind it is a quiet warning. Even our most familiar star is capable of storms big enough to shake technology, disrupt power systems, and flood space with radiation. The Sun is a reminder that cosmic radiation isn't far away. It doesn't live in distant galaxies. It begins right in our own cosmic neighborhood, one heartbeat of nuclear fire away from Earth. Fact 12. Radiation from supernova explosions. The cosmic shockwaves of death and creation. A star dying is one of the most dramatic events in the universe. When a massive star runs out of fuel, it collapses inward, then explodes outward with unimaginable force. A supernova. In that moment, the star becomes a cosmic bomb, blasting radiation and particles across galaxies. If the Sun exploded like this, which it won't since it's too small, the energy would be powerful enough to wipe out life on Earth instantly. That's how intense a supernova is. It is nature's ultimate reset button. During a supernova, particles are accelerated to near light speed. These high-velocity protons and atomic nuclei become cosmic rays, so powerful that they can travel thousands of light years and still smash into Earth's atmosphere with enough force to create showers of secondary particles. What's amazing is that these destructive blasts also give rise to the elements that make up planets and life. The gold in your jewelry, the iron in your blood, the oxygen you breathe, all forged in ancient supernovas. These explosions seed galaxies with the elements necessary for planets and life. So cosmic radiation from a supernova isn't just a threat, it's a gift wrapped in danger. Every time one of these particles hits Earth, it carries a story from a star that died millions of years ago. A final whisper from a cosmic furnace that ended violently so that new worlds, and perhaps new lives, could begin. The universe never wastes energy. Even destruction becomes creation. Fact 13. Gamma-ray bursts. The most powerful cosmic flash in the universe. Imagine a beam of energy so intense that, if one pointed directly at Earth from thousands of light years away, it could strip our atmosphere and sterilize the planet. That terrifying burst of radiation has a name, a gamma-ray burst, or GRB. These bursts are the brightest and most powerful explosions ever recorded. Some come from collapsing giant stars turning into black holes. Others happen when two neutron stars collide in a crash so powerful it bends space-time. For a few seconds or minutes, these events release more energy than an entire galaxy. We don't see them often. They are rare and usually far away. But when they happen, telescopes detect a powerful flash of gamma radiation. For scientists, it's like hearing a thunderclap from the edge of the universe and then rushing to see what caused it. The incredible part? We may owe life to them. Some theories suggest that ancient gamma-ray bursts long before humans existed helped shape the chemical evolution of galaxies. Others believe a GRB in Earth's prehistoric past may have triggered a mass extinction. They are deadly. They are mysterious. They are one of the universe's loudest warnings that unimaginable power exists out there, and we are only tiny witnesses to it. Fact 14. Black holes and cosmic radiation. Jets. Darkness that shines. A black hole is a region so dense, so powerful that not even light can escape its pull. It sounds like the ultimate silence, a place where everything disappears forever. But surprisingly, black holes can also be some of the brightest objects in the universe. When material spirals toward a black hole, it heats up to extreme temperatures and emits enormous energy. Sometimes, instead of swallowing everything, the black hole blasts some of it away in huge jets of radiation and charged particles that stretch for thousands of light years. These jets travel near the speed of light, true cosmic weaponry. These jets can shape entire galaxies, ignite star formation in distant clouds, or tear cosmic gas apart. They flood space with energetic particles, another major source of cosmic radiation. It's a strange thought. The darkest objects in existence are also powerful sources of light and energy. They hide nothingness, yet radiate force strong enough to be seen across the universe. Next time someone says black holes only destroy, remember this. Even in the deepest darkness, the universe finds ways to shine. Fact 15. Pulsars and magnetars, spinning giants that fire radiation. Like lighthouses, after a massive star explodes, sometimes it leaves behind a neutron star of an object so dense that a teaspoon of its matter would weigh billions of tons. Now imagine that star spinning rapidly, shooting beams of energy from its poles as it spins. That's a pulsar, a cosmic lighthouse flashing radio waves, X-rays, and sometimes gamma rays across space. Some pulsars spin hundreds of times per second. Each rotation sends a pulse of radiation sweeping through space. When one of those beams crosses Earth, we detect a rhythmic tick, like a heartbeat left behind by a dead star. And then there are magnetars. Pulsars on steroids. They have magnetic fields 1 trillion times stronger than Earth's. Their magnetic power can rip atoms apart. When they flare, they release bursts of high-energy particles and radiation that travel far into the galaxy. To us, they look like blinking stars. But in reality, they are wounded giants, collapsed cores of dead suns, spinning and screaming energy into the void. They are reminders that even when stars die, they don't fall quiet. They continue to echo through time. Cosmic radiation is not only a product of explosions or chaos. Sometimes it is the steady beat of a dead star's rotation, a heartbeat that never truly fades. Fact 16. Cosmic rays from other galaxies. Messages from distant universes. When we look up at the night sky, we see stars from our galaxy, the Milky Way. But cosmic rays don't respect borders. Some of the particles hitting Earth every second started their journey not just thousands of light years away, but millions, even billions. They come from other galaxies entirely, travelers from worlds we will never see with our naked eyes. Imagine a particle beginning its life near a star in a distant galaxy, perhaps born in a violent explosion, the remains of a sun we never knew existed. It is pushed, accelerated, and thrown into space with unimaginable force. It drifts for eons, weaving through nebulae, passing cosmic dust and dying stars, slipping between galaxy clusters like a silent messenger from the cosmos. And after this journey, a trip longer than all human history, it reaches Earth. It collides with our atmosphere and creates a chain reaction of secondary particles. For a moment, the sky flashes invisibly with cosmic fireworks, and then it disappears. We don't know exactly how many of these particles reach us, but we know they come. They are proof that the universe is connected in ways we are only beginning to understand. Every cosmic ray from another galaxy is a whisper from somewhere unimaginably far away, a place with its own suns, planets, maybe even life. So when cosmic radiation touches Earth, remember, some of it began its journey before humans, before civilization, before our planet even finished cooling. We are struck every moment by ancient travellers from the edge of existence. Fact 17. Cosmic rays from star-forming regions, born in stellar nurseries. Where do stars come from? In giant clouds of gas and dust. Places astronomers call stellar nurseries, stars are born. We imagine these nurseries as peaceful, glowing clouds, but inside them, the universe is violent and busy. Stars form, planets begin to gather, gravity squeezes matter, and intense magnetic fields twist and snap. In these chaotic cradles of creation, cosmic rays are also born. Young stars blast powerful radiation. Shockwaves from stellar winds collide. Massive stars, not yet old but already fierce, throw out particles at incredible speeds. Some stars may even collapse into neutron stars or explode while still inside these regions, sending cosmic rays scattering outward. To us, these cosmic regions look like colourful nebulae through telescopes, soft, magical clouds. But in reality, they are energetic war zones. Creation in the universe often comes with chaos. Just as life on Earth began in turbulent oceans and lightning storms, stars are born in cosmic storms, and those storms fling radiation across space. When those particles travel across space and arrive here, they remind us of our own beginnings. We come from stardust, and the universe sends us constant proof, particle by particle. Fact 18. Cosmic radiation. From the Big Bang. The oldest signal in existence. Long before stars, planets, or galaxies existed, there was a moment that created everything, the Big Bang. From that explosion came space, time, matter, and all the forces of nature. Most of that event is lost to us, hidden behind billions of years of cosmic history. But not everything faded. A faint echo remains. Cosmic background radiation. It fills the universe like a quiet afterglow, a soft whisper left behind by creation itself. This radiation is not dangerous, it is extremely weak today, but it is everywhere. Every direction astronomers look, they find the same faint signal, the same ancient heat. It is the oldest form of cosmic radiation we know. Imagine a photograph taken at the moment the universe became transparent, when light could finally travel freely. That is what this radiation is. A snapshot of the universe as a newborn, only 380,000 years old. Compared to that, humanity is a blink. Earth is a blink. Even stars are a blink. Cosmic background radiation is proof that the universe remembers its birth. And we, tiny humans on a small planet, have learned how to listen to that memory. In a way, the Big Bang still touches us. Not through force, but through quiet presence. A soft static hum across space, reminding us where everything began. Fact 19. Dark matter decay. A theoretical source of cosmic rays. Dark matter is one of the biggest mysteries in science. We can't see it, touch it, or detect it directly. Yet we know it exists because it shapes galaxies and bends light with its gravity. But what if dark matter does more than just hide in the shadows of physics? What if it sometimes breaks apart, and when it does, releases cosmic radiation? This is the theory some scientists are exploring. If dark matter particles are unstable, they might decay or collide, producing energetic particles that could be detected as cosmic rays. It's still just an idea. No one has caught dark matter in the act yet. But experiments deep underground, in Antarctic ice, and in orbit around Earth are searching for hints. Imagine a hidden world in the universe, a vast ocean of invisible matter surrounding galaxies, and sometimes, rarely, silently, one of its particles shatters. When it does, it sends a ghost-like message, a burst of energy racing through space. If we ever confirm this, it would change physics forever. Cosmic radiation might not only come from stars and explosions, it could come from something older, stranger, and far more mysterious, the invisible foundation of the universe itself. Fact 20. Cosmic rays from quasars. The beating hearts of ancient galaxies. Quasars are the bright, furious cores of distant galaxies, powered by supermassive black holes consuming matter at incredible rates. As material falls toward the black hole, enormous jets of energy burst outward, lighting up space and firing high-energy particles across the cosmos. Some of the most powerful cosmic rays detected may have started near quasars. These particles are so energetic they push the limits of physics. They travel millions of light years, defying distance, surviving cosmic obstacles, and eventually striking our atmosphere as tiny messengers from ancient galactic hearts. Quasars are among the brightest objects ever found. They shine brighter than entire galaxies, even though the source may be only as large as our solar system. To see one is to look back in time. Many existed when the universe was still young, when galaxies were just beginning to form. So when a cosmic ray from a quasar hits Earth, it's like receiving a postcard from the early universe, a whisper from a time when galaxies were wild and young, ruled by hungry black holes blazing with unimaginable power. We live on a tiny planet circling an ordinary star, but the universe still reaches out to touch us, from galaxies we will never visit, from ages long before humans, from engines of creation and destruction burning at the edge of time. Fact 21. Cosmic rays travelling near light speed, racing through the universe. Imagine something moving so fast it could circle the Earth 7 times in 1 second. Now imagine it isn't a spaceship or some futuristic engine, it's a tiny particle, a cosmic ray, flying through space at nearly the speed of light. That's how intense the universe can be. Cosmic rays aren't gentle travellers. They're like bullets fired by exploding stars, devouring black holes, and cosmic storms beyond imagination. Once they're launched, they don't stroll through space. They sprint, 99% the speed of light. Faster than anything we can build, faster than anything our bodies or machines could withstand. Sometimes I imagine a cosmic ray leaving a supernova, a star collapsing and exploding at the same time. That particle is blasted outward, surrounded by chaos and light so bright it would blind us instantly. And instead of slowing down, it accelerates. Space isn't empty. It's a highway filled with gravity, magnetic fields, dust, and strange forces, but cosmic rays punch through it all. What's wild is that many cosmic rays striking Earth started their journey long before humans existed. Some were born before the dinosaurs, before Earth had oceans. They race across the universe for millions, sometimes billions of years, only to collide with our planet and vanish in a single heartbeat, and we barely notice. So the next time you look up, remember, the sky isn't quiet, it's a racetrack. A cosmic marathon has been happening above our heads forever. And we are constantly being touched by travellers moving almost as fast as the universe allows. Proof of the raw power hidden in every corner of existence. Fact 22. Magnetic fields. Bending cosmic rays. Invisible roads in space. We like to think of space as simple, just floating stars and planets in emptiness. But in truth, space has structure. Not solid walls or roads, but invisible highways made of magnetic fields. And cosmic rays, they don't get to choose their path. They are pushed, twisted, bent, and redirected by these magnetic forces like leaves in the wind. Every star has a magnetic field. Every planet, galaxy, and even clusters of galaxies. Think of them like invisible spiderwebs stretching across space. When a cosmic ray comes flying through, it rarely goes straight. It curves, it arcs, it spins. It follows invisible rules written into the universe's fabric. Because of this, we often can't trace cosmic rays back to where they came from. Their journey's not a beam of light. It's a wild, chaotic dance, a zigzag through cosmic weather. It's funny, the universe hides its secrets well. Even when particles travel billions of years, we still can't always point and say, they came from there. Magnetic fields erase their footprints like waves wiping sand. And yet, this bending doesn't weaken the poetry of it. If anything, it adds mystery. When cosmic rays arrive, they carry not a clear map, but a story tangled in the magnetic heartbeat of the cosmos. Fact 23. Why cosmic rays don't move in straight lines. The universe isn't flat and simple. In school, we learn that light travels in a straight line. It makes space sound clean and predictable. But cosmic rays live a different life. They are charged particles, and charged particles don't get to move freely in the universe. They react, they respond, they get pushed around. Picture a tiny particle trying to travel across the universe. On its way, it meets galaxies with swirling magnetic arms, planets with magnetic armour, black holes twisting space-time, and star winds roaring like cosmic hurricanes. It's like trying to walk straight in a world made of rivers, storms, and whirlpools. Cosmic rays curve because the universe isn't empty. It's alive with energy and force. So instead of a straight flight, they're flung around like billiard balls hitting countless invisible bumpers. Sometimes that journey takes millions of years instead of thousands. Sometimes cosmic rays end up arriving at Earth from completely different directions than where they started. Imagine trying to follow a message that's been rewritten 1,000 times on the way. That's how cosmic rays tell their story. It reminds us of something humbling. Even the smallest particle feels the universe's influence. Nothing moves alone here. Everything bends, responds, and dances to cosmic forces far bigger than itself. Fact 24. How cosmic rays interact with interstellar dust. Tiny collisions, big consequences. Between stars, space isn't empty. It's filled with dust. Tiny grains of matter left over from dying stars, floating quietly in the dark. We don't see it with our eyes, but it's there, shaping galaxies and forming planets, and cosmic rays crash into this dust all the time. These collisions are tiny, unbelievably tiny, yet powerful. When a cosmic ray hits dust, it can break it apart, heat it, or trigger reactions that create new molecules. Some scientists think cosmic rays may have helped form the building blocks of life by striking dust and gas clouds, creating complex chemicals that later came together to form planets and eventually, us. Imagine that for a moment. Life might owe something to particles flying through invisible dust clouds billions of years ago. The universe doesn't just explode, it builds, it recycles, it transforms. Little by little, cosmic rays help sculpt the cosmos, grain by grain. Even today, this process continues. Dust floats between stars like cosmic pollen, and cosmic rays move like wild bees, stirring, shaping, and changing what they touch. Quiet work, invisible to us, yet fundamental to the universe's story. Fact 25. Cosmic background radiation in empty space, the afterglow of creation. When we point antennas toward empty space, we don't hear silence. We hear a faint static, a soft whisper of ancient heat left over from the Big Bang. Cosmic background radiation fills every corner of the universe, even places where there are no stars, no dust, no galaxies, just emptiness. It's not harmful, it's not loud, it's gentle, like the warmth left in a room after a fire goes out. And yet, this faint echo is one of the most important discoveries in science. It tells us the universe had a beginning. It carries the fingerprint of creation. Close your eyes and picture the universe shortly after the Big Bang, hot, glowing, chaotic. As it expanded and cooled, that light stretched and faded but never vanished. Today, it sits quietly between stars and galaxies, like a memory that refuses to disappear. Even in the most silent parts of space, the universe remembers where it came from. Sometimes we imagine emptiness as nothing, but cosmic background radiation reminds us, even nothingness has history, even silence carries a story, and we are able to hear it. Tiny humans, listening to the oldest light in existence. Fact 26. Cosmic rays entering the solar system, crossing into our neighbourhood. Think of the solar system as a quiet neighbourhood in a massive cosmic city. Most days everything seems calm. Planets orbit peacefully. The sun glows steadily. Space feels silent. But outside this peaceful bubble, the universe is chaotic, filled with explosions, storms, and restless energy. And every moment, cosmic rays from far-off places try to break in. As these high-energy particles approach our solar system, it's almost like they're stepping through a doorway. On one side, deep interstellar space, wild and unpredictable. On the other, the sun's domain. A region shaped by solar wind, magnetic fields, and the protective boundaries of our star. But cosmic rays don't knock politely. They arrive fast, nearly at the speed of light, moving with the reckless force of ancient explosions. Many of them make it through. Some come from dead stars, some from galaxies we can barely see, and when they enter our solar system, their path changes. They begin to feel the sun, its magnetic field twisting space like an invisible rope, its wind pushing against them like a river current. It's strange to imagine, isn't it? Something so small, so distant, yet so powerful that it never really stops. It just keeps going, crossing boundaries, slipping through cosmic borders until one day it may reach Earth, or miss us entirely and continue drifting forever. The solar system isn't locked away from the universe. It's constantly being touched by it. Every second, particles born in other corners of existence step into our sky, tiny visitors reminding us we're part of something vast. Fact 27. Effect of solar wind on cosmic rays. The sun's invisible armour. The sun is not quiet. It doesn't just shine. It breathes. It sends out streams of charged particles in every direction, forming the solar wind. If space were water, the solar wind would be waves crashing outward from the sun, pushing back against the universe. Cosmic rays trying to enter feel this wind, like trying to walk against a strong storm. Some get slowed, redirected, or turned away. When the sun is active, during solar storms or flares, this effect becomes even stronger. It's as if the sun raises its shield and says, "Not today." The funny thing, the sun doesn't do this for us. This isn't protection with purpose, it's simply nature, raw and powerful. But we benefit from it. During high solar activity, fewer cosmic rays reach Earth. During quiet sun periods, more seep through. So the sun isn't just a source of life-giving light. It's a guardian in a way, constantly pushing against cosmic chaos. Not deliberately, but effectively. It's easy to forget how powerful our star truly is. We see it as warm, golden, familiar. But in space, it's a warrior, magnetic, fierce, and always moving. Fact 28. Earth's magnetic field as a shield, our invisible guardian. If we could see Earth's magnetic field, it would stretch far into space, curved like a giant protective bubble. We live inside it without noticing, barely understanding that this invisible force saves us every second. Cosmic rays rushing toward Earth meet this magnetic field and get pushed aside, slowed, or trapped. It acts like a shield, not perfect, not impenetrable, but strong. Without it, cosmic radiation would rain down on us constantly, turning our atmosphere into a danger zone. Life as we know it might not exist. I like to imagine the magnetic field as a quiet guardian. No sound, no colour. No movement we can see, yet always there, wrapping the planet like a protective cloak, created by molten metal deep inside Earth, swirling like a cosmic engine, generating a force we rarely think about. When cosmic rays approach, they feel it. They bend, they spiral, they get deflected like arrows hitting armour. Some still reach us. Nothing in nature is absolute, but far fewer than there could be. It's humbling. We survive not just because Earth has oceans or oxygen, but because our planet built a magnetic wall between us and the universe's wildness. A silent defender, older than humanity, older than every story we've ever told. Fact 29. Radiation belts, Van Allen belts, trapped particles above our heads. Above Earth, far beyond airplanes and weather, lie rings of radiation, called the Van Allen belts. At first thought, that sounds alarming. Rings of radiation surrounding the planet. But they are not our enemy. They're part of Earth's defense system. They are where some cosmic rays get trapped, caught in magnetic storms circling the planet like prisoners in orbit. NASA discovered them in the 1950s, and even today, they feel almost mystical. Glowing belts of charged particles swirling in magnetic currents. They pulse, shift, and respond to solar activity. Sometimes they swell, sometimes they shrink. Space isn't static. Even our protective layers breathe. For astronauts, the belts are dangerous to cross without shielding. But for Earth's surface, they act like filters. Every time a cosmic ray ends up stuck there, it's one less particle hitting the atmosphere below. They aren't shields in the traditional sense, more like nets catching energetic debris. There's beauty in that. Even the space around us is alive with movement, with layers and forces working quietly to protect our fragile world. Fact 30. Cosmic rays hitting the atmosphere, invisible fireworks above us. Every second, cosmic rays slam into our atmosphere. We don't see them, they're silent, invisible. But when they hit, they create showers of particles, like microscopic fireworks exploding high above us. A single cosmic ray can strike a molecule in the air and split into dozens of new particles, then hundreds. These scatter downward, some reaching the ground, some stopping in the air. It happens constantly, or day and night, everywhere on Earth. You've been touched by cosmic rays today without knowing it. That sounds dramatic, but life has grown used to it. The atmosphere absorbs most of the energy, shielding us like a giant protective blanket. Without it, cosmic rays would tear through us the way they do on Mars, a planet too exposed, too quiet, lacking the layers of protection we are blessed with. Sometimes I think about those invisible collisions, tiny battles happening above us every moment. The universe throws energy at us, and Earth catches it, absorbs it, transforms it into harmless light or harmless particles. Cosmic rays hitting the atmosphere aren't just a threat, they're a reminder. The universe is active, alive, always moving, and we live in a pocket of safety carved out by nature over billions of years, protected by our magnetic field, our sun, our atmosphere, and forces we never see but rely on every second. Act 31. Cosmic rays create secondary particles on Earth. The universe's invisible domino effect. Imagine a single tiny traveller from space, a cosmic ray smashing into Earth's atmosphere. You might think it simply disappears, absorbed by the air, but the story doesn't end there. That one particle sets off a chain reaction, a cascade of new particles shooting in all directions, secondary cosmic rays. These secondaries are like invisible fireworks above us. One proton strikes a nitrogen atom, releasing neutrons, electrons, and muons. Those particles collide with other air molecules, creating even more. By the time the cascade reaches lower layers, dozens, sometimes hundreds of particles are moving through the atmosphere at incredible speeds. And yet it all happens silently, invisibly, above our heads, every moment of every day. Scientists detect these showers with sophisticated instruments, tracking the invisible footprints of cosmic travellers that started millions of light years away. It's almost poetic. A single cosmic event millions of years ago leads to a shower of particles striking our planet today. Earth is constantly touched by the universe, an intimate connection, invisible to our eyes but profound in reality. Fact 32. Formation of muons in the atmosphere. Ghost particles falling from the sky. One of the most intriguing secondary particles produced by cosmic rays is the muon. Imagine a particle so elusive that it can pass through dozens of meters of rock, even your body, without leaving a mark. Muons are created high in the atmosphere when cosmic rays smash into air molecules, breaking them apart and sending new particles cascading down. They are everywhere. Trillions pass through your body every second. Most vanish without effect, but they carry information about the cosmos. Scientists use them to study volcanoes, pyramids, and even the interiors of reactors. A muon is like a ghostly messenger, born from the collisions of cosmic rays, travelling silently from the sky to us, connecting the heavens and the earth in ways we can barely imagine. Muons remind us that the universe interacts with us constantly, silently and intimately. Every step outside is like walking through a river of cosmic whispers. Fact 33. Cosmic rays helping form clouds. The cloud seeding theory. Some scientists believe cosmic rays don't just collide, they influence our weather. According to the cloud seeding theory, when cosmic rays hit the atmosphere, they ionize air molecules, creating tiny seeds around which water droplets can condense. These seeds can grow into clouds. It's not proven, but it's fascinating to imagine. Invisible particles travelling from distant stars and galaxies, helping shape the clouds above your city, your mountains, your oceans. Every day, cosmic rays could be nudging rainfall, forming mist, shaping storms. The universe not only watches over us, it might subtly influence the weather we experience, one particle at a time. Whether true or not, it's a humbling thought that particles born in violent explosions light years away could have a hand in something as ordinary and vital as a cloud floating over your head. Fact 34. Natural radiation exposure from the universe. We live in a cosmic shower. We often think radiation is dangerous, something artificial, controlled in labs, feared in hospitals. But Earth has always existed in a cosmic bath. Cosmic rays, solar wind, gamma radiation. We are constantly exposed naturally. In fact, the average person gets about 0.3 millisieverts of radiation from space every year. That's small, harmless, and yet omnipresent. It's invisible. You don't feel it, you don't notice it, but it's there, touching every molecule, passing through every cell, mountains, plains, oceans. No place is untouched, and life adapted. We evolved in this quiet radiation storm. It's part of our environment, our history, our very biology. So, when thinking about cosmic radiation, don't just picture danger, picture coexistence. The universe is constantly interacting with us, gently and invisibly, teaching life how to thrive amid constant energy. Fact 35. Cosmic rays and lightning formation. Theories: a shocking connection. Lightning is one of nature's most powerful displays, a sudden, brilliant release of energy from storm clouds. But what triggers it? Some scientists believe cosmic rays play a role. When they hit the atmosphere, they ionize air, creating paths of charged particles. These paths can act as triggers for electrical discharges, turning a storm into a lightning show. Imagine a particle born millions of light years away, crashing into the atmosphere, nudging electrons and helping a bolt of lightning form. The universe subtly influencing one of Earth's most dramatic phenomena, all without intention, all without notice. It's almost poetic. A tiny cosmic traveller helping write the script of storms on our planet. It's a reminder that cosmic rays aren't just distant or abstract. They can touch the world in ways visible, dramatic, and life-altering. The universe is quietly connected to everything, even the spark of a thunderstorm. Fact 36. Influence on Earth's climate. The possible link. The idea that cosmic rays could influence Earth's climate sounds like science fiction, but scientists have been exploring it for decades. It all starts with the same particles we've been talking about, high-energy cosmic rays raining down from space. Some studies suggest that when these particles ionize the atmosphere, they may help clouds form, subtly affecting how much sunlight reaches the surface. Think of it like this. Cosmic rays might act as tiny climate nudges, creating the seeds for clouds that reflect sunlight or hold heat in. Over millions of years, fluctuations in cosmic ray intensity, caused by solar activity or passing through different parts of the galaxy, could have nudged Earth's climate in warmer or cooler directions. It's not the only factor. Greenhouse gases, ocean currents, and volcanoes all play huge roles. But it's fascinating to imagine that the universe beyond our solar system might have its fingers on Earth's thermostat. A supernova millions of light years away, or a change in our sun's magnetic activity, could subtly sway weather patterns here at home. It's a reminder that even forces light years away can leave traces on our tiny blue planet. Cosmic rays are not just abstract energy. They may be quiet participants in the climate story unfolding around us every day. Fact 37. Cosmic radiation and the ozone layer, a delicate interaction. The ozone layer high above Earth protects life from harmful ultraviolet radiation. But did you know cosmic rays interact with it too? When these high-energy particles collide with molecules in the upper atmosphere, they can trigger reactions that create or destroy certain chemicals. Most of these effects are minor, but they highlight an important truth. The ozone layer isn't isolated. It's part of a dynamic system influenced by the sun, human activity, and yes, cosmic radiation. In areas of strong cosmic ray influx, like near the poles or during intense solar events, chemical changes in the upper atmosphere can occur, subtly affecting ozone concentration. It's a quiet, invisible dance of particles and molecules. No one feels it, but the universe constantly tests and shapes the protective shield we often take for granted. Life on Earth owes its safety to layers we cannot see, constantly interacting with invisible cosmic forces. Fact 38. How mountains increase radiation exposure, standing in the universe's crossfire. Have you ever wondered why high-altitude cities like La Paz in Bolivia or Lhasa in Tibet have slightly higher radiation levels? It's because cosmic rays are hitting the atmosphere above, and there's less air to protect you at higher elevations. The thinner the atmosphere, the fewer collisions occur to absorb or deflect cosmic rays before they reach the surface. Mountains are like standing closer to space. Every breath you take, every particle passing through, is part of a stream that began in exploding stars, energetic galaxies, and ancient cosmic events. Hikers and climbers are quietly walking through invisible showers of cosmic energy, most harmless, some detectable by scientific instruments. It's fascinating to realize that elevation isn't just a geographic measure, it's a direct line to the universe. The higher you go, the more the cosmos touches you, reminding you that our planet isn't an isolated bubble. It's a small stage in a vast energetic play. Fact 39. Radiation levels at high altitudes. Touching the sky, feeling the universe. Flying at 35,000 feet, you're above much of the atmosphere. You might enjoy the view of clouds below, but you're also in a region where cosmic rays are far more intense. Without the dense air of lower altitudes, there's less shielding, and high-energy particles pass through freely. Instruments on planes measure increased radiation levels, sometimes several times higher than at sea level. Pilots, cabin crew, and frequent flyers are subtly exposed every flight. It's not enough to cause immediate harm, but it's a reminder that the universe doesn't stop at the edge of our atmosphere. It reaches us, bending, colliding, and whispering across the sky. Airplanes and mountaintops are unique vantage points, places where we can feel the cosmic connection most tangibly. The universe brushes past us here more than anywhere else on the planet. Fact 40. Why airline pilots and crew receive more radiation. Living in cosmic showers. Pilots and flight attendants spend thousands of hours at high altitudes, cruising above much of the protective atmosphere. That means they're exposed to more cosmic rays than the rest of us. Over time, this exposure accumulates, though still within safety limits, and is a daily reminder that Earth's protection is strongest at sea level. It's not dangerous in most cases, but it's an invisible occupational hazard, a reminder that the universe is always reaching in. Each flight carries them through a cosmic shower, brushing past particles born in supernova, pulsars, and even galaxies far beyond our own. For them, work is a blend of engineering and cosmic physics. The sky isn't empty, it's alive with energetic travellers, and pilots and crew spend more time walking through that invisible storm than anyone else, feeling the universe's touch in a way few of us ever will. Fact 41. Cosmic radiation and cancer risk. The invisible threat. Cosmic rays are everywhere, silently raining down on Earth. For most of us, they're harmless. Our atmosphere and magnetic field do an incredible job shielding life. But there's a question scientists keep asking. Could cosmic radiation increase cancer risk? High-energy particles can penetrate cells, damaging DNA in ways natural processes don't always repair perfectly. The risk is small for most people living at sea level, but it becomes more significant for those spending long periods at high altitudes. Airline pilots, astronauts, and people living in mountainous regions. Space travelers face an even greater challenge. Beyond the protective cocoon of Earth's atmosphere, they're exposed to constant cosmic showers. NASA and other space agencies monitor radiation carefully, planning missions to minimize long-term health effects. Still, cosmic rays are a reminder that life is constantly negotiating with the universe's energy. For us on the ground, the risk is subtle. It's part of a quiet balance between the cosmos and life. Cosmic radiation is a force of nature, powerful, ancient, and largely invisible, that we've learned to live with. Fact 42. Radiation and DNA damage. When particles rewrite the code of life, DNA is the blueprint of life, delicate, precise, and essential. Cosmic rays carry enough energy to disrupt it. When they collide with molecules in our cells, they can break chemical bonds, sometimes altering the DNA sequence. A single cosmic ray might split a strand or create a mutation that the body must repair. Our cells are prepared for this. DNA repair mechanisms constantly fix minor damage, and most cosmic hits go unnoticed. But every now and then, the damage is imperfect, leaving a permanent change. This is why scientists study cosmic radiation so closely. It's nature's invisible pen, occasionally rewriting the instructions of life. The fascinating part is how resilient life is. Humans evolved under constant exposure to cosmic rays. Our biology is adapted to survive countless collisions over millions of years. Cosmic rays remind us that even the universe's smallest particles can touch the essence of life itself. Fact 43. Radiation causing cell mutations. Tiny sparks of change. Mutations are the raw material of evolution, and cosmic rays can be one of the sources. When radiation strikes a cell, it can rearrange, break, or modify its DNA, leading to mutations. Most of these changes are harmless. Some can even be beneficial over time, contributing to evolution. Others, though rare, may increase disease risk. It's almost poetic. Cosmic rays are born in exploding stars, pulsars, or distant galaxies, travel millions of light years, and ultimately touch our cells in quiet, invisible ways. They're a cosmic reminder that life on Earth is connected to events far beyond our planet, that we are, in part, shaped by the universe itself. Even more intriguing, some researchers suggest that these tiny cosmic sparks may have played a role in life's adaptability. The universe nudges evolution slowly, silently, particle by particle. Fact 44. Why humans don't notice cosmic radiation. A silent visitor. Cosmic rays pass through our bodies every moment, yet we rarely notice. Why? Because our atmosphere, magnetic field, and biological defenses do their job quietly and effectively. The radiation is mostly invisible, mostly harmless, and our cells are constantly repairing minor damage. It's a strange thought. Trillions of high-energy particles from exploding stars and distant galaxies pass through you every day. And yet, life goes on as if nothing happened. Cosmic radiation is the universe's quiet handshake, a reminder that the world outside our senses is more energetic, alive, and mysterious than we imagine. We've evolved not to feel it, not to react, and in doing so, life continues undisturbed, even under a constant shower from the stars. Fact 45. Cosmic radiation versus X-rays and CT scans. A comparison. We're familiar with medical radiation, X-rays, CT scans, MRI machines, devices that give precise doses to see inside the body. Cosmic rays are different. They're unpredictable, high-energy particles from space, often far more energetic than most medical radiation. A single cosmic ray can carry more energy than a dental X-ray, but Earth's atmosphere absorbs most of them. Only a tiny fraction reaches humans, unlike a CT scan, where doctors intentionally target your body with radiation. Interestingly, both cosmic rays and medical radiation interact with DNA in similar ways, breaking bonds and creating small changes. But while medical exposure is controlled and temporary, cosmic radiation is constant, passive, and largely harmless thanks to natural shielding. The comparison reminds us that radiation isn't inherently dangerous. Context, intensity, and protection matter. The universe showers us with energy, and we've learned to live with it, much like we carefully use tools on Earth to probe our own bodies safely. Fact 46. Radiation dose. Measurements, sieverts. Quantifying the invisible radiation is invisible, silent, and all around us. So how do scientists measure it? Enter the sievert, a unit that quantifies the effect of radiation on human tissue. One sievert represents the potential impact on cells and DNA, giving us a way to compare cosmic rays, X-rays, or nuclear exposure. Imagine trying to weigh sunlight or feel a breeze you can't see. That's what measuring radiation is like. Scientists developed the sievert to give context to these invisible energy particles. A chest X-ray might deliver 0.1 millisieverts. Living at sea level, you get about 0.3 millisieverts a year from cosmic rays. Understanding the dose is essential. It tells doctors when medical imaging is safe, informs space agencies about astronaut exposure, and helps researchers assess long-term cosmic radiation risk. Without a way to measure, cosmic rays would be untouchable mysteries, intangible forces brushing past us unnoticed. The sievert makes the invisible visible. It gives numbers to the universe's quiet touches, letting us navigate, survive, and study them with precision. Fact 47. Safe versus harmful radiation. Dose levels. Finding the threshold. Radiation is everywhere, but not all doses are dangerous. The key is exposure. Small doses, like those we receive from the sun, or cosmic rays at sea level, are harmless. Our bodies repair minor damage easily. A sunny day, a flight across the Atlantic, or a dental X-ray barely scratches the threshold. Harmful doses are much higher, typically measured in sieverts rather than millisieverts. Acute exposure above 1 sievert can cause radiation sickness. Chronic exposure over time increases cancer risk. Astronauts, nuclear workers, and people living near unusual radiation sources need monitoring, because the universe doesn't adjust its energy output for humans. It's fascinating how life evolved to tolerate low-level radiation. The universe constantly sends energy our way, but Earth's magnetic field, Atmosphere and repair systems keep most of it in check. Understanding safe versus harmful levels allows us to explore, travel, and live safely, even under an invisible rain of cosmic particles. Fact 48. How the body repairs radiation damage. Nature's invisible fixes. Every time cosmic rays pass through us, they leave tiny marks in our DNA. Most go unnoticed because our cells are equipped with repair mechanisms. Enzymes detect broken DNA strands, remove damaged segments, and replace them with correct sequences. It's like an invisible repair crew working tirelessly inside every cell. Sometimes the repair is perfect, sometimes small mistakes remain. These minor changes are usually harmless but can occasionally lead to mutations. Over millions of years, this repair system allowed life to survive constant cosmic bombardment. Think of it as life's secret defense system. While we sleep, walk, or work, cells silently fix tiny disruptions from radiation. Without it, the universe's invisible energy showers would accumulate damage too fast, and life as we know it wouldn't exist. Cosmic rays are constant, but our bodies are relentless guardians. Fact 49. Why astronauts risk radiation sickness. Beyond Earth's shield, astronauts leave the protective embrace of Earth's atmosphere and magnetic field. Beyond this shield, cosmic rays, solar flares, and high-energy particles bombard the body constantly. In deep space, exposure can be hundreds of times higher than on Earth. Even with protective spacecraft, the risk is real. High-energy particles can penetrate shielding, strike cells, and overwhelm repair systems if exposure is prolonged. That's why astronauts limit time in space, carefully monitor their health, and rely on shielding technology. It's a reminder that venturing beyond Earth isn't just about rockets and engineering. It's a dance with invisible cosmic forces, a negotiation with particles that have travelled millions of light years just to meet us. Space travel is awe-inspiring, but it's also a game of patience, protection, and respect for the universe's raw power. Fact 50. Radiation effects on the brain in space. Cosmic rays and cognition. The human brain is delicate, and cosmic rays don't discriminate. High-energy particles can penetrate shielding, striking neural tissue. Studies suggest prolonged exposure in space might affect memory, cognition, and motor skills, although research is ongoing. Some experiments with animal models indicate that cosmic radiation can trigger inflammation in brain cells or disrupt communication between neurons. Astronauts on long missions may experience subtle changes in focus, attention, or decision-making. It's a quiet reminder. The universe interacts not just with our bodies, but with our minds. Space is beautiful, expansive, and inspiring, but the brain, like every other organ, feels the invisible touch of cosmic energy. Life beyond Earth requires both courage and adaptation to these unseen forces. Fact 51. Danger of cosmic rays to spacecraft electronics. The universe strikes back. Space isn't empty. It's filled with high-energy cosmic rays, travelling at nearly the speed of light. For humans, our atmosphere and magnetic field absorb most of it. But for spacecraft electronics, these particles are a formidable enemy. Cosmic rays can penetrate metal, circuit boards, and microchips. They cause glitches, flip bits, and sometimes permanently damage sensitive electronics. A simple cosmic ray can turn a 0 into a 1, crashing software, confusing sensors, or even disabling a spacecraft. That's why engineers design redundancy into every critical system. Building spacecraft as if the universe itself might test them. It's poetic in a way. Rockets and satellites leave the comfort of Earth's protective cocoon, only to face an invisible storm of particles from exploding stars, distant galaxies, and ancient cosmic events. Every mission becomes a quiet battle between human technology and the raw power of the cosmos. Fact 52. Shielding astronauts from radiation, building cosmic armor. Astronauts venturing beyond Earth's protective layers face a constant shower of high-energy particles. To survive, they need shielding, but not just walls. Shielding in space must be lightweight, yet dense enough to block or absorb cosmic rays. Materials like polyethylene, water, and specialized metals are carefully arranged in spacecraft to reduce exposure. Even then, shielding is imperfect. High-energy particles can penetrate, producing secondary radiation inside the spacecraft. That's why mission planners also use timing, flight paths, and magnetic fields where possible to minimize exposure. Space isn't just a vacuum, it's a high-energy obstacle course. Shielding astronauts is a silent race against invisible enemies. It's a blend of physics, engineering, and imagination, creating a protective cocoon in a universe that constantly pushes back. Fact 53. Radiation on the ISS, living in low Earth orbit. The International Space Station orbits above much of Earth's atmosphere in low Earth orbit. Astronauts on the ISS are exposed to more cosmic rays than we are on the ground, about 100 times higher than natural background radiation at sea level. Luckily, Earth's magnetic field still protects them from the worst particles. Shielding in the station's modules further reduces exposure, but astronauts still carry dosimeters to monitor every cosmic interaction. Solar storms can temporarily increase radiation levels, forcing crews to retreat to shielded areas. Life on the ISS is a delicate balance. Daily routines, science experiments, even exercise are all done under the quiet influence of cosmic radiation. The station floats in an invisible storm, reminding us that even in orbit, humans remain connected to the vast energetic universe. Fact 54. Radiation levels on the Moon, a bare exposed world. The Moon has no atmosphere, no magnetic field, no shield. Cosmic rays strike it directly, bathing the surface in energetic particles. For future lunar bases, this means astronauts and equipment are under constant radiation pressure. Moon dust itself can become charged and interact with cosmic rays, producing secondary radiation. Living there won't be like Earth. It will be a constant negotiation with energy we cannot see. Lunar habitats will need thick shielding, perhaps using regolith, moon soil, as armor to protect humans from cosmic bombardment. Walking on the Moon isn't just a leap for mankind, it's stepping into a world exposed to the universe in ways Earthlings rarely experience. Each footstep is a silent dance with cosmic energy. Fact 55. Radiation challenges for Mars missions. Facing the red planet storms, Mars is the next frontier, but it's even harsher than the Moon. Thin atmosphere, weak magnetic field. Astronauts heading there will face constant cosmic rays, solar storms, and high-energy particles. Long missions mean cumulative exposure could be significant, increasing cancer risk and affecting long-term health. Space agencies are exploring every solution: heavy shielding, magnetic deflection systems, and even timing launches to avoid peak solar activity. Daily life on Mars will be measured not just in oxygen and food, but in radiation doses, shielding, and cosmic awareness. Every step toward the red planet is a negotiation with invisible forces. Cosmic rays are relentless, traveling across millions of light-years to greet humanity in its next adventure. Mars isn't just a destination, it's a laboratory where humans test resilience against the universe itself. Fact 56. Mars has no magnetic field, higher radiation. Mars is often called the Red Planet, a barren, beautiful world. But there's one thing that makes it extremely hostile. It has no global magnetic field. On Earth, our magnetic field acts like an invisible shield, bending cosmic rays away and protecting the surface. Mars has none of that. Without this magnetic armor, cosmic rays and solar energetic particles hit the Martian surface directly. Any future astronauts will face constant radiation exposure, much higher than on Earth. Even the thin atmosphere only partially absorbs the particles. Imagine standing on Mars. The sky might look calm, but invisible energy from exploding stars, distant galaxies, and solar flares is bombarding the ground. Every molecule, every cell is touched by a force we can't see. Living there won't just be about oxygen or temperature, it's about surviving an unrelenting cosmic storm. Fact 57. Spacesuits and radiation protection limits. Armor for the final frontier. Astronauts rely on spacesuits to survive the harsh vacuum of space, but these suits have limits. They protect against temperature extremes, micrometeoroids, and some radiation. Yet high-energy cosmic rays can penetrate spacesuits, and prolonged exposure in deep space can still be dangerous. Spacesuits are designed to block lower-energy particles, but the most energetic cosmic rays pass through almost like ghosts. That's why astronauts on long missions like a trip to Mars need more than just suits. They need habitats with dense shielding, magnetic protection concepts, and careful planning around solar activity. Spacesuits are the first layer of defense, but they are not invincible. They remind us that exploring space means constantly balancing risk, technology, and the invisible universe pressing in from every direction. Fact 58. Solar storms and space radiation spikes, the sun's sudden fury. The sun seems calm from Earth, a glowing, steady star, but sometimes it erupts violently. Solar flares and coronal mass ejections send enormous bursts of charged particles hurtling into space. When these reach astronauts or spacecraft, radiation levels spike dramatically. These solar storms can temporarily increase cosmic radiation exposure many times over. Astronauts aboard the ISS or on missions beyond Earth must retreat to shielded areas, sometimes for hours or days. Electronic systems can also be affected, forcing engineers to design robust backups. It's a reminder that space is alive. The sun is not just a source of light and warmth, it's a dynamic force, capable of turning a calm orbit into a sudden particle storm. Space travel means respecting these invisible dangers, planning for them, and living in sync with the cosmos. Fact 59. How NASA monitors cosmic radiation, tracking the invisible storm. NASA doesn't leave radiation to chance. On the ISS, spacecraft and satellites, specialized detectors continuously monitor cosmic radiation. Instruments like dosimeters measure particle energy, flux, and spikes from solar events. Data is relayed back to Earth, guiding decisions on crew safety, mission timing, and spacecraft design. Astronauts wear personal dosimeters to track individual exposure. Engineers use the data to strengthen shielding, reroute missions, or even adjust work schedules during solar storms. Monitoring cosmic radiation isn't just science, it's survival. NASA's monitoring reminds us that while cosmic rays are invisible, they are never ignored. The universe's energy is powerful, unpredictable, and relentless, and staying aware is the first step to safely exploring beyond Earth. Fact 60. Spacecraft electronics hardening. Tough tech for a harsh universe. Cosmic rays don't only threaten humans. Spacecraft electronics are under constant assault. High-energy particles can flip bits, erase memory, or disable entire systems. That's why engineers harden electronics with special design techniques, redundant circuits, radiation-tolerant materials, error-correcting software, and protective shielding. Every deep space probe, Mars rover, and satellite must survive this invisible storm. Cosmic rays can't be avoided, but they can be managed. Engineers anticipate collisions, plan for worst-case scenarios, and build spacecraft that can shrug off particle strikes without catastrophic failure. It's a quiet battle happening far from our eyes. While astronauts float or rovers roll across distant planets, engineers wage war on particles we can't see. Every piece of hardening is a tiny victory against a universe that never rests. Fact 61. Cosmic radiation helps study the universe, nature's messenger. Cosmic rays aren't just a challenge or a danger, they're messengers. Every particle that reaches Earth carries a story from distant corners of the universe. Scientists detect them, measure their energy, and trace their origin, learning about events millions or even billions of light years away. Imagine a particle born in a supernova explosion, travelling across galaxies for eons, finally colliding with our atmosphere. That tiny collision carries clues about the star, the explosion, and the cosmic neighbourhood it travelled through. Cosmic rays are like letters in bottles, sent across space and time, revealing secrets of the universe we could never see otherwise. They teach us about energy scales, particle physics, and cosmic history. Without them, much of the universe's high-energy story would remain invisible, hidden behind light we cannot always detect. Cosmic rays make the invisible universe tangible. Fact 62. Cosmic rays as clues to star death, tracing explosions across light years. Stars die in spectacular ways. Some collapse quietly, but many explode as supernovae, releasing enormous energy and cosmic rays. By studying these rays, scientists can identify where and how stars ended their lives. Each particle is a messenger of a stellar finale. A cosmic ray detected on Earth might have originated in a supernova millions of years ago, carrying the fingerprints of that cataclysmic event. Scientists can decode this information to understand the star's mass, age, and even the processes that led to its explosion. It's humbling to think, when we study cosmic rays, we are witnessing distant deaths across time. The universe is vast, chaotic, and beautiful, and these tiny high-energy travelers connect us intimately to events we could never see directly. Fact 63. Studying cosmic rays to understand black holes. Probing the invisible. Black holes are invisible, but their influence is immense. They accelerate particles to extreme energies, sometimes creating cosmic rays that escape their grip. By detecting these rays, scientists can study black holes indirectly. High-energy particles carry clues about magnetic fields, acceleration mechanisms, and the dynamics near the event horizon. Cosmic rays act like fingerprints left behind by these enigmatic objects. Each particle that reaches Earth is a piece of a puzzle, revealing the invisible forces at play around some of the universe's most extreme objects. Studying cosmic rays is like detective work on a cosmic scale. It's our way of probing places light cannot escape and learning about the forces that shape galaxies, stars, and space itself. Fact 64. Cosmic rays and dark matter research. Chasing the invisible. Dark matter is one of the universe's greatest mysteries. We can't see it, touch it, or measure it directly, but cosmic rays might offer clues. Certain high-energy particles could be produced when dark matter decays or interacts, leaving subtle signals in cosmic ray measurements. By analysing anomalies in cosmic ray data, scientists search for patterns that might indicate dark matter's presence. It's indirect, tricky, and requires extreme precision, but it's one of the few ways we can study this invisible component of the cosmos. Cosmic rays, born from stars, galaxies, and supernovae, may also carry whispers of the unseen matter that shapes the universe. It's a fascinating idea. The universe may be communicating with us through these energetic messengers, pointing to the invisible structures that govern cosmic evolution. Fact 65. Cosmic rays helping measure. Galactic magnetic fields. Mapping the invisible force, galaxies are threaded with magnetic fields we cannot see, shaping star formation, cosmic rays, and galactic evolution. Cosmic rays act as tracers, moving along these fields, bent and twisted by their influence. By studying the direction, energy, and spread of cosmic rays, scientists can map galactic magnetic fields. These particles carry hidden information about the structure, strength, and orientation of the invisible forces controlling galaxies. It's like using tiny messengers to map an invisible web stretching across light years. Each cosmic ray that reaches our detectors is a thread in that map, helping us understand how galaxies are held together, how they evolve, and how cosmic energy flows through them. Through cosmic rays, the invisible becomes measurable, and the universe becomes a story we can begin to read. Fact 66. Radiation. Revealing Earth's atmospheric history, particles as time capsules, cosmic rays do more than tell us about distant stars. They also tell stories about our own planet. When high-energy particles strike the atmosphere, they create isotopes, special versions of elements, that accumulate in ice, rocks, and tree rings. Scientists analyze isotopes like carbon-14 and beryllium-10 to reconstruct Earth's atmospheric history. These isotopes act as tiny clocks, showing changes in solar activity, magnetic field strength, and cosmic ray intensity over millennia. By studying them, we can understand ancient climate patterns, solar storms, and even events like supernova explosions that briefly increased cosmic ray flux on Earth. It's poetic to think that particles from exploding stars millions of light-years away have left a record of our planet's history. Cosmic rays are invisible scribes, writing on ice, rocks, and trees, telling us the story of both the universe and Earth itself. Fact 67. Cosmic rays used in particle physics discoveries. Unlocking nature's secrets. Long before massive particle accelerators existed, cosmic rays were our first laboratory for extreme physics. High-energy particles arriving from space collide with Earth's atmosphere at energies far beyond what early accelerators could achieve. By studying these collisions, scientists discovered new particles like the positron, antimatter's mirror image of the electron, and muons. Cosmic rays acted as nature's particle accelerator, providing glimpses into the fundamental building blocks of the universe. Even today, cosmic rays complement laboratory experiments. They allow physicists to explore energies and reactions impossible on Earth. Every particle reaching our detectors is a tiny clue, showing the universe's rules in action, helping us understand matter, energy, and the forces that shape reality. Fact 68. Cosmic rays and neutrino studies. Following the ghost particles, neutrinos are elusive, almost massless particles that rarely interact with matter. Interestingly, cosmic rays are a major source of neutrinos, created when cosmic rays smash into atmospheric molecules. These neutrinos pass through Earth and detectors, carrying information about their origin. Studying neutrinos helps scientists probe the Sun, supernovae, and even distant galaxies. Cosmic rays are, in a sense, messengers that produce neutrinos for us to study. Without them, understanding these ghostly particles would be far more difficult. It's fascinating. High-energy particles born in distant cosmic explosions ultimately allow us to study one of the universe's most mysterious building blocks. Cosmic rays and neutrinos are partners in revealing the invisible side of reality. Fact 69. Cosmic rays help study antimatter, messengers of the mirror world. Antimatter is the mysterious counterpart to normal matter, identical in mass but opposite in charge. Cosmic rays occasionally produce antimatter particles like positrons when they collide with atoms in the atmosphere. By studying these rare antimatter events, scientists test fundamental physics, search for dark matter, and explore why our universe is dominated by matter rather than antimatter. Cosmic rays act as tiny laboratories in the sky, naturally producing the extreme conditions needed to create antimatter. It's poetic. Invisible particles travelling millions of light years give us glimpses of a mirror universe, helping answer questions humans have pondered for centuries. Cosmic rays are nature's experiment, continuously offering insights into the building blocks of everything we see. Fact 70. High energy versus low energy cosmic rays. Understanding the spectrum of space. Not all cosmic rays are created equal. Some are low energy, barely making it through Earth's atmosphere, while others are ultra-high energy particles with the force to traverse galaxies almost unaffected. High-energy cosmic rays are rare, but their effects are dramatic, creating massive particle showers when they hit the atmosphere. Low-energy rays are more common and interact with atmospheric molecules more frequently. Studying the spectrum helps scientists understand cosmic ray origins, acceleration mechanisms, and how they influence Earth. It's like tuning in to different channels of the universe. Each energy level tells a different story: nearby solar flares, distant supernova, or unknown extragalactic sources. Cosmic rays are a spectrum of messages, each particle a word in the universe's story. Fact 71. Radiation detectors on satellites. Eyes in space. Satellites orbiting Earth don't just take pictures or relay signals. Many carry instruments to detect cosmic rays. Above most of the atmosphere, these detectors capture particles that would never reach the ground. Satellites measure energy, type, and direction of cosmic rays, providing scientists with a clear view of the universe's energetic messengers. Some track solar storms in real time, helping protect astronauts and satellites from radiation surges. Others study distant galaxies, supernovae, or even hints of dark matter. It's incredible to think that tiny detectors on a metal spacecraft are quietly catching particles born millions of light years away. These satellites are our cosmic eavesdroppers, translating the universe's invisible energy into knowledge we can use and understand. Fact 72. Ground-based cosmic ray detectors, catching particles on Earth. Even on the ground, cosmic rays can be studied. Specialized detectors, like scintillators, water Cherenkov tanks, or muon detectors, capture secondary particles created when cosmic rays hit the atmosphere. These instruments allow scientists to measure the flux, energy, and composition of cosmic rays. Networks of detectors around the world even track cosmic ray showers from rare high-energy events, giving insight into distant cosmic explosions. Imagine standing near one of these detectors. Invisible particles from exploding stars and distant galaxies are constantly passing through, and this small instrument is silently counting them, helping us map the universe's energetic activity. Ground-based detection brings the cosmos closer to our daily experience, connecting Earth to distant phenomena. Fact 73. balloon experiments for cosmic rays, reaching the edge of space. Before satellites were common, scientists used balloons to study cosmic rays. High-altitude balloons carry detectors to the edge of the atmosphere, above most of Earth's shielding, where cosmic rays hit with more energy. These balloons float silently, thousands of meters above the ground, capturing data about cosmic ray intensity, particle types, and solar effects. Some balloons carry instruments into stratospheric heights for days or weeks, providing crucial insights into particle interactions and atmospheric chemistry. It's poetic. A simple balloon becomes a bridge between Earth and the cosmos, drifting through the invisible storms of high-energy particles, silently recording the universe's energetic whispers for curious minds below. Fact 74. Particle accelerators versus cosmic rays. Earth's lab versus nature's lab. Particle accelerators like CERN's Large Hadron Collider are human-made tools to smash particles at incredible speeds, recreating high-energy physics on Earth. But cosmic rays often exceed the energies achievable in labs, striking Earth naturally with extreme power. Scientists study both. Accelerators provide controlled experiments, while cosmic rays show how particles behave under extreme natural conditions. Every cosmic ray collision is an unscripted experiment, giving insights into fundamental forces, particle interactions, and rare phenomena that labs can't easily replicate. It's like comparing a carefully controlled classroom experiment to a wild natural storm. Both teach us physics, but cosmic rays bring the raw energy of the universe directly to Earth's doorstep. Fact 75. Cloud chambers and cosmic ray tracks. Seeing the invisible. Early cosmic ray studies often used cloud chambers, simple yet brilliant devices that make invisible particles visible. When high-energy particles pass through a supercooled gas, they leave trails of tiny droplets, like luminous paths in the air. Scientists could watch muons, electrons, and other secondary particles streak across the chamber, turning abstract invisible energy into something tangible. These tracks help discover new particles and confirm theories, providing the first visual proof of cosmic rays in action. It's magical to imagine. Invisible messengers from exploding stars creating sparkling trails in a chamber on Earth, connecting us visually to events millions of light years away. Cloud chambers brought the universe into our hands, one particle track at a time. Fact 76. Geiger counters and cosmic background. Listening to the universe. Geiger counters are classic tools for detecting radiation. Most people think of them in labs or nuclear facilities, but they can also detect cosmic rays passing through the atmosphere. Even in a quiet room at sea level, a Geiger counter will occasionally click. A tiny particle from outer space just passed through. These clicks are more than random noise. They are whispers of the universe's energy, part of a cosmic background that surrounds us constantly. By using Geiger counters in different locations or altitudes, scientists can measure variations in cosmic ray intensity and even track solar activity indirectly. It's remarkable that such a simple device can connect us to phenomena occurring millions of light years away. Every click is a tiny handshake from the cosmos, reminding us that we live in a universe alive with invisible energy. Fact 77. Cosmic ray observatories. Listening to the sky. To study the universe's most energetic cosmic rays, scientists built huge observatories like the Pierre Auger Observatory in Argentina. Covering thousands of square kilometers with detectors, water tanks, and fluorescence telescopes, these observatories track particle showers created when cosmic rays collide with Earth's atmosphere. They capture rare events, some caused by particles so energetic they challenge our understanding of physics. Each detection helps map cosmic ray origins, energy levels, and trajectories. Observatories like these are massive listening posts patiently recording the universe's energetic stories day and night. It's awe-inspiring. Invisible particles traveling across galaxies end up triggering sensors on Earth, letting humans witness phenomena far beyond our eyes. Cosmic ray observatories turn Earth itself into a window to the universe. Fact 78. Ice cube neutrino detector and cosmic rays. Watching ghost particles in Antarctica. Buried deep in the ice cube neutrino detector quietly listens for neutrinos. Cosmic rays striking the atmosphere create showers of secondary particles, including neutrinos, nearly invisible particles that rarely interact with matter. IceCube uses thousands of sensors embedded in the ice to catch the faint flashes of light, produced when neutrinos collide with atomic nuclei. By analyzing these interactions, scientists trace cosmic rays' origins and study distant cosmic events like supernovae and black holes. It's amazing to think that particles created in distant galaxies are being caught in Antarctic ice, revealing secrets about the universe's most energetic and elusive phenomena. Cosmic rays and neutrinos together help us see what light alone cannot show. Fact 79. Space telescopes. Tracking radiation, eyes above the atmosphere. Space telescopes aren't just for images of galaxies and stars. Many are designed to track high-energy radiation. Above Earth's protective atmosphere, instruments detect gamma rays, X-rays and cosmic rays directly, without interference. Telescopes like the Fermi Gamma Ray Space Telescope provide data about distant supernovae, pulsars, and black holes. They complement ground-based detectors, allowing scientists to track cosmic rays' origins, energy, and behavior in space. Being above the atmosphere means seeing the universe's high-energy events in their purest form. These telescopes are silent sentinels, continuously monitoring radiation, capturing signals that reveal the universe's hidden energetic landscape. Fact 80. Smartphone cosmic ray detection experiments. Science in your pocket. Believe it or not, your smartphone can help detect cosmic rays. Special apps turn the camera sensor into a mini radiation detector. When a high-energy particle passes through, it creates a tiny light event that the app records. Thousands of citizen scientists worldwide use this method to track cosmic rays, contributing real data to scientific projects. It's a simple yet powerful example of how modern technology allows anyone to participate in cosmic research. Your pocket device, mostly for social media and photos, can become a window to the universe. Every particle detected is a tiny connection to distant stars, supernovae and galaxies, reminding us that the cosmos is always reaching out, and sometimes you can catch it in your hand. Fact 81. Radiation exposure. During flights, invisible, high-altitude guests. When you fly at 35,000 feet, the view outside the window is breathtaking. But up there, you're also exposed to more cosmic radiation than at sea level. At high altitudes, the atmosphere is thinner, meaning more high-energy particles can reach passengers and crew. For a typical flight, the exposure is small, similar to a single chest X-ray. But frequent flyers and pilots accumulate more over time. Airlines and regulators monitor this carefully, ensuring doses stay well below harmful levels. It's invisible, silent, and mostly harmless, yet it's a constant reminder that Earth's atmosphere is our shield. Flying connects us to the universe in unexpected ways. Every particle passing through the cabin is a tiny messenger from the stars, a reminder that even 10 kilometers above ground we remain part of the cosmos. Fact 82. Radiation from granite and rocks. Earth's own cosmic shield. Earth itself emits radiation. Granite, certain rocks and soils naturally contain radioactive elements like uranium, thorium, and potassium-40. These elements release alpha, beta, and gamma radiation, adding to the background exposure we live with every day. Cosmic rays interacting with these materials can even produce secondary particles. Living in areas with granite-rich soil slightly increases radiation exposure, but it's usually within safe limits. It's fascinating to realize that cosmic radiation and terrestrial radiation coexist, creating a dynamic, invisible energy landscape around us. The Earth isn't just a passive surface, it's part of the radiation story, both shielding us and contributing its own particles to the cosmic symphony. Fact 83. Cosmic rays at the poles versus equator, magnetic field at work. Earth's magnetic field doesn't just protect us from cosmic rays, it shapes where and how many reach the surface. Near the equator, the magnetic field is strongest, deflecting most cosmic rays. Near the poles, the field lines are more vertical, letting more high-energy particles penetrate. This is why researchers in Antarctica or the Arctic experience higher cosmic ray flux than at mid-latitudes. Even airlines flying over polar routes see slightly higher radiation levels. Earth's magnetic field acts like a funnel and filter, shaping a radiation landscape that varies from pole to equator. It's a reminder that the universe's energy interacts constantly with our planet, sculpting patterns invisible to our eyes but measurable by instruments and careful observation. Fact 84. Daily and yearly variation in cosmic rays. Cosmic rhythms. Cosmic ray exposure isn't constant. Solar activity, Earth's orbit, and magnetic field changes create daily and yearly variations. During solar maximums, the Sun's magnetic field shields Earth more effectively, slightly reducing cosmic ray intensity. During solar minimums, cosmic rays reach Earth more easily. Daily changes also occur as Earth rotates, slightly altering exposure depending on magnetic field orientation and atmospheric conditions. These fluctuations are small but measurable, giving scientists insight into solar activity, cosmic ray propagation, and even Earth's magnetosphere. Cosmic rays remind us that the universe is dynamic. Invisible energy flows ebb and rise, silently interacting with our planet's systems, marking rhythms that stretch from minutes to decades. Fact 85. Cosmic rays and nuclear reactor. Similarities. Energy in action. Cosmic rays and nuclear reactors may seem worlds apart, but they share similarities. Both involve high-energy particles interacting with matter, creating secondary particles, and transferring energy that can affect surrounding materials. When cosmic rays hit the atmosphere, they produce showers of secondary particles, like a natural chain reaction. Nuclear reactors control similar processes artificially, managing particle interactions to produce energy safely. Understanding cosmic rays has even helped physicists design reactors and shielding techniques. Nature was experimenting with high-energy particles long before humans built reactors. Observing the cosmos gives us insights into physics that apply both in deep space and right here on Earth. Fact 86. Cosmic rays and air travel safety limits. Flying in an invisible storm. Flying may feel routine, but every passenger is brushing against cosmic energy thousands of meters above Earth. Airlines calculate radiation exposure carefully, ensuring flights stay well within safety limits. Pilots and crew, who spend hundreds of hours in the sky, are monitored even more closely. The exposure is measured in millisieverts, tiny compared to harmful levels. A cross-continental flight might give you a fraction of a chest X-ray. Still, cosmic rays are a reminder that at cruising altitude the protective atmosphere is thinner, letting more high-energy particles through. Air travel combines technology, physics, and careful monitoring to make it safe. Every click of invisible cosmic particles passing through the cabin is a gentle reminder. The universe is vast, energetic, and always present, even during a comfortable flight. Fact 87. Cosmic rays. Creating carbon-14. Particles that tell time. One of the most fascinating contributions of cosmic rays is to archaeology. When cosmic rays strike nitrogen atoms in the atmosphere, they produce carbon-14, a radioactive isotope. This isotope is absorbed by living organisms, creating a natural clock. After death, the carbon-14 decays predictably. Scientists use this decay to date ancient wood, bones, or artifacts. Every carbon-14 measurement is essentially reading the history of cosmic rays interacting with our atmosphere over thousands of years. It's incredible to realize that exploding stars millions of light-years away indirectly help us understand human history. Cosmic rays, traveling across the universe, leave traces that allow archaeologists to unlock stories buried for millennia. Fact 88. Radiation in underground labs. Hiding from cosmic rays. To study subtle particle interactions, scientists build underground laboratories, shielding experiments from cosmic rays. Deep under mountains or in mines, the Earth itself absorbs most high-energy particles, creating a quiet, controlled environment. These labs allow detection of rare events, neutrino interactions, dark matter searches, and other phenomena that cosmic rays would otherwise drown out. By escaping the constant bombardment, researchers can study the universe's most delicate and elusive particles with precision. It's fascinating to think that even though the universe is energetic and chaotic, we can carve out tiny pockets of calm underground, where the whispers of the cosmos can be studied in peace. Fact 89. Cosmic radiation versus radon gas. Different invisible threats. Cosmic radiation isn't the only invisible energy around us. Radon gas, a naturally occurring radioactive element in soil and rocks, also contributes to our radiation exposure. Unlike cosmic rays, radon is local, emitted directly from the ground, and can accumulate in basements or enclosed spaces. Both are invisible and energetic, but their effects differ. Cosmic rays are high energy, transient particles that pass through us quickly, while radon releases low-energy radiation over longer periods, primarily affecting lungs if inhaled. Together, they make up the background radiation that surrounds all life on Earth. Understanding both helps scientists distinguish natural risks from cosmic phenomena, ensuring safety while also appreciating the universe's constant influence. Fact 90. Cosmic rays and electrical system interference. When particles hit technology, cosmic rays don't just interact with humans, they can disrupt electronics. High-energy particles can flip bits in microchips, cause temporary malfunctions, or even trigger serious errors in satellites, aircraft systems, and power grids. Engineers call these single-event upsets, and designing electronics to withstand them is critical for space missions and high-altitude aircraft. Cosmic rays act as an invisible testing force, challenging our technology daily. It's humbling. While we build and rely on advanced electronics, the universe quietly sends energetic particles to probe our creations. Cosmic rays remind us that even human ingenuity must coexist with the raw energy of space. Fact 91. Ultra-high energy cosmic rays, UHECR. Nature's particle titans. Some cosmic rays are extreme. Ultra-high energy cosmic rays, or UHECRs, carry energies millions of times higher than what human-made accelerators can achieve. These particles are rare, but when they arrive, they create enormous showers of secondary particles in the atmosphere, spreading over kilometers. Scientists still puzzle over how they reach such energies. Supernovae, active galactic nuclei, or exotic phenomena like gamma-ray bursts are possible sources. Detecting UX requires vast observatories, like the Pierre Auger Observatory, capable of tracking these rare, powerful messengers. Imagine a single particle from across the universe, traveling billions of light-years, smashing into our atmosphere with unimaginable energy. It's a reminder of the raw, almost poetic power of nature, and that the universe still holds secrets far beyond human reach. Fact 92. The mystery of cosmic ray. Origins. Chasing invisible travelers. Cosmic rays are everywhere, yet their exact origins remain partly mysterious. Some come from our sun, others from supernovae, pulsars, or distant galaxies. But ultra-high energy cosmic rays challenge scientists, as no single source fully explains their extreme energies. Researchers combine satellite data, ground observatories, and theoretical models to trace these particles. Every detection narrows the possibilities, but the universe keeps teasing us. Some rays may originate from black holes, quasars, or even unknown exotic phenomena. The mystery adds excitement. Every cosmic ray that hits Earth is a puzzle piece from distant cosmic events. We are detectives in a universe of invisible messengers, chasing secrets carried by particles that have travelled across space and time. Fact 93. Cosmic rays. Hitting electronics and flipping bits. Technology under fire. High-energy cosmic rays are invisible, but their effects on electronics are tangible. When a particle collides with a microchip, it can flip a bit, turning a 0 into a 1. This may crash software, confuse sensors, or trigger errors in satellites, aircraft, and even high-altitude electronics. Engineers call these single-event upsets. Designing electronics to resist them involves redundancy, error-correcting software, and radiation-hardened components. Despite precautions, cosmic rays remain a subtle, persistent threat, silently probing our technology. It's a reminder. While humans build complex systems, the universe constantly tests them with energy that has travelled millions of light-years. Our technology is resilient, but it's never completely immune to cosmic whispers. Fact 94. Cosmic rays causing airplane navigation errors, invisible hazards at 35,000 feet. Flying high exposes airplanes to more cosmic rays. Occasionally, these particles interact with onboard electronics, potentially causing minor errors in navigation or instrumentation. Though extremely rare, pilots and engineers account for these effects in design and safety protocols. Advanced aircraft systems include error correction and shielding to prevent cosmic rays from interfering with critical functions. It's fascinating to think that invisible particles from distant stars occasionally touch human technology directly, affecting journeys thousands of kilometers from Earth. Flying becomes more than a routine trip. It's a dance with cosmic energy. Every particle passing through the cockpit is a reminder of the universe's constant presence, even when we feel safely enclosed in steel and sky. Fact 95. Astronauts seeing radiation, flashes in their eyes, cosmic light show. Some astronauts in space report seeing brief flashes of light, even when their eyes are closed. These are caused by cosmic rays penetrating the retina or surrounding tissues, directly interacting with cells and creating tiny bursts of visual perception. This phenomenon, called cosmic ray visual phenomena, is more common outside Earth's protective atmosphere, such as on the ISS or during deep space missions. It's a direct, personal encounter with high-energy particles, a reminder that the universe isn't just abstract. It can be felt and even seen. Astronauts' flashes are proof that cosmic rays are everywhere, invisible yet powerful. They turn the universe into a personal, intimate experience, literally touching human perception in ways impossible on the surface of Earth. Fact 96. Radiation storms that could disrupt satellites. Space weather warnings. The universe isn't always calm. Solar flares and coronal mass ejections can produce intense radiation storms, sending high-energy particles hurtling through space. Satellites orbiting Earth can be caught in these storms, experiencing temporary malfunctions, software glitches, or even permanent damage. Operators track these storms using space weather monitoring systems. Warnings allow satellites to enter safe modes or reorient shielding to minimize exposure. Cosmic rays aren't just abstract phenomena. They are a real invisible threat to the technology humans depend on. It's fascinating to think that distant solar activity and cosmic energy can ripple across space to touch our machines, reminding us that space is a dynamic, living environment. Satellites are both explorers and test subjects in this invisible storm. Fact 97. Cosmic radiation. Increasing. During solar minimum, when the sun lets go. The sun goes through an 11-year cycle of activity. During solar maximum, its magnetic field shields Earth more effectively, reducing cosmic ray intensity. During solar minimum, however, the sun's protective influence weakens, and cosmic radiation reaching Earth increases significantly. Astronauts, satellites, and even high-altitude flights face slightly higher exposure during these periods. Scientists carefully monitor these cycles to adjust safety protocols and predict radiation spikes. It's a reminder that even subtle changes in our star's behavior can ripple across space, affecting particles that have traveled millions of light-years to reach us. Cosmic rays, in a way, respond to the sun's rhythms, creating a cosmic heartbeat that interacts with our planet and technology. Fact 98. Radiation shielding. Experiments with fungi on ISS. Nature meets space. On the ISS, scientists are experimenting with fungi that might protect against cosmic radiation. Certain fungi produce melanin, which absorbs radiation, potentially reducing exposure to astronauts. These experiments explore using biology, not just metal or water, as shielding. If successful, it could transform long-term space travel, creating living, self-repairing shields that adapt to cosmic conditions. Cosmic rays become not just a hazard, but a catalyst for innovation, inspiring scientists to merge life and technology for protection. It's poetic. Nature, evolved on Earth, may help humans survive in the harsh, energetic universe beyond our atmosphere. Cosmic rays challenge us, and life itself may provide solutions. Fact 99. Radiation maps of the universe. Seeing the invisible. Cosmic rays help create detailed maps of radiation across the universe. Satellites and detectors chart energetic particles from supernovae, pulsars, black holes, and distant galaxies, showing the universe's hidden energetic landscape. These maps reveal patterns invisible to regular telescopes, tracing galactic magnetic fields, identifying cosmic accelerators, and even hinting at exotic phenomena like dark matter interactions. By mapping radiation, scientists turn chaos into structure, understanding how energy flows across space. It's a reminder that the universe is alive with invisible activity. Cosmic rays act as cartographers, painting a map of forces that shape galaxies and influence everything from star formation to planetary protection. Fact 100. Why cosmic radiation will shape the future of space travel, preparing for the invisible frontier. As humans venture farther from Earth, to the Moon, Mars and beyond, cosmic radiation will be one of the biggest challenges. It influences spacecraft design, mission duration, astronaut safety, and even future colony planning. Learning to monitor, shield against, and perhaps even harness cosmic rays is essential for sustainable exploration. New materials, magnetic shielding, and even biological solutions like radiation. Absorbing fungi may become standard. Cosmic rays are invisible teachers, forcing humanity to innovate and adapt for survival in space. Ultimately, understanding cosmic radiation isn't just a scientific curiosity. It's central to our future in the stars. Every particle, every storm, every burst of energy informs how we will live, work, and thrive beyond our home planet. The universe is shaping our destiny, one cosmic ray at a time.